Hello, everybody. Welcome back to Logos Dev Club. Thank you for being here. I am Chair. I'm here to prop you up. Logos Dev Club is your home for Logos technical content every week. We feature Logos contributors, collaborators, partners, developers, engineers, thinkers, researchers. You will find it all here at the Logos Dev Club. Today, we have an incredible program put together for you. I am flying solo, but we will embark on a journey together. We have 2 demos, hot and fresh out the kitchen, very fresh. Václav and Sasha, 2 Logos EcoDev champions. You will watch along with me and we'll take the journey together. I will probably pause frequently and ask questions, mostly to myself in the ether, but follow along in the chat. Say hello in the chat if you are out there, wherever you might be watching. Chat works. Go to logos.co to start your journey, especially if you have not yet visited the brand new logos.co. Parallel Society, rapidly approaching. It is this week. Get your tickets to Parallel Society Lisbon this week, March 6th and 7th. ps.logos.co. Technical conference on the 6th. A music festival on the 7th. A slew of partners. Very cool partners. Ton of incredible music acts. ps.logos.co. Parallel Society is right around the corner. Wherever you might be watching now, please like, subscribe, follow, turn notifications on. Things are ramping up, as you will gather from this pair of demos that will be coming at you immediately. First up, we will have Sasha demoing the Scaffold Logos repo. Very much takes inspiration from the Scaffold ETH project and repo from Austin Griffith and Build Guild, or the Biddle Giddle. Then Václav will demo his Multisig functionality on the Logos execution zone using some agentic magic tricks, courtesy of Claudebot, or OpenClaw, or whatever they're calling themselves today. My favorite nickname so far, Red Botster. So we will have Václav on the back end. First up is Sasha. Once again, if you have not purchased your tickets for Parallel Society, do so immediately. ps.logos.co. First up, we have Sasha, who will be demoing boom, the Logos Scaffold project. Come on this journey with me.
logo scaffold package, how to use it, and what it has so far. So right now we are at 0.1 version. We do support
If you can
development
hear the
for
audio
LEZ only,
just fine.
and only on local net, which means locally run sequencer. We do experiment with additional capabilities for writing programs, such as LEZ framework, which means just a set of macros that are useful for for writing your program. For example, private and public state and PDA primitives. Essentially, just a set of macros. There are two templates: default and LEZ framework, which is pretty much work in progress. Each of them is well documented, so just navigate and you'll see. Otherwise, you can access it through CLI after bootstrapping, or just after bootstrapping the project with appropriate template.
It's the logos-co GitHub organization. The logos-scaffold repo is where and what we are looking at.
So, in order to use Scaffold, you need to install it. Oh, yeah. You need to install it. I already have it. Then let's bootstrap something. Feel free to use -help. And you can use it also on all subcommands. They're pretty much self-explanatory. So let's create a new package project. If you want to use a template, you just do template and name of the template, and then name of the project. But because LEZ is work in progress and it's quite heavy, I'll show you only default.
Help you out the Zoom.
The template, which is essentially hello world programs that also exist in LSSA repository. So, well, it shows us what it does on each and every step, the scaffold. So we are using the default template. We are using, let's say, this version, and we also have some cache. So let's navigate to there. Let me show you a bit of the structure. So we have two special things to Scaffold. Scaffolded projects. First is a scaffold configuration file. It captures all the necessary bits of information for this particular scaffolding, so we can track it. In README, you can see how to use this project and other important things, how to interact with programs as well. So here is an example how to interact with one of the variants of Hello World. Please do it on your own. It should be working. In this demo, I want to focus on Scaffold. So there is also a special folder, .scaffold. In this, you can see like commands again, and also some state and logs, and some other stuff will be added there over time while you use the project. Why it's needed is that we want to capture this later on to provide better support, and so that community can provide you better support. So this is the idea. The programs are located in this folder, and the programs that can execute them are in this folder. This is quite standard right now. And also we want to continue supporting .env files. So right now, as I said, only local development is supported. In 0.2, we will add, I expect we will add support for testnet and a bunch of other stuff. So that's gonna be useful if you want to differentiate between environments and keep some secrets. So that's it. But I would like to set an expectation that logo scaffold will be reinvented each and every version, because well, all this is very dynamic. They're moving forward, and we're gonna be learning on our lessons a lot. So the project is here. What we want.
Yeah, it's a big takeaway there, as Sasha just mentioned. Things are dynamic at the moment as Logos rapidly iterates on everything. So certainly this scaffold project will have to constantly be updated as things are constantly being shipped. Right now, things are limited to a local development environment, but as the testnet rolls out, the Scaffold Logos project will be updated, will be available to those who seek to use it.
To do well, read README, but one of the commands that stand out is setup. So it's setup. What it does is that it sets up our environment as well as some additional things. So it sets up a wallet CLI from LSD. It also primes it to particular with particular seeds so that we can have the same wallet addresses between projects. You can see like configuration of the wallet here. If you need to debug or like investigate it, we keep a wallet state so that you don't need to copy paste your most frequently used wallet. Just a little thing. So let's continue. So now as we set up the environment, we want to do maybe building. But before that, I advise you, as a rule of thumb, to run doctor command. What it does is that it checks our environment, checks some meta information, and tells us if all good and we can proceed. So here it tells us that we have a warning and
Like
we
a good
probably
doctor
want to
command.
do local net start. So let's do this. I start it and I run into a problem. So it tells me that the port is occupied and there is a process that occupies it. If you see it, most likely you already have a running sequencer. What we want is we want to restart it because the sequencer is running for another project, which has its own state, and we would like to have it freshly running for our project for local development, just so that we can capture logs for our particular interruptions. Hence, we are killing it, and we are starting the scaffold again. It executed, it's ready, and once it's ready, you're gonna see the logs in this file, in the logs folder, in this system folder, in this .scaffold directory. They will be populated over time. Another way to access them is to, you can see there is a bunch of other stuff, but you can do logs, and you can tail them, and you can tail some exact amount. So you can also stop this the local sequencer here, but let's continue. You probably would like to maybe top up your wallet. For this, we created some shortcuts. It's just convenient shortcuts for builders. We will iterate, and most likely we will do some other ways for improving development experience here as well. So right now it's capable of listing your wallets. You can see your wallets here. It is capable of topping up your wallet.
Pinata. I like it.
It takes a bit of time. But once it's done, you will see the transaction hash and other information, or you're gonna see logs about what failed. You also see what exactly gets executed. This is for consumers' convenience here, and also for
your
maybe
convenience.
debugging. So you see, we have, I guess, succeeded. This is a transaction. So we are good to go with the wallet. Let's see what else we can do. So we can build a project and we can deploy. Well, we probably need to start building it. So let's build. There are, depending on the template you would use, you'll see, you might find it useful to know like particular build steps. So here is like for LZ framework, it's important to build IDL as well as the project itself. So it would require 2 steps. You can use just cargo build, but since some templates might be more sophisticated and it might be more difficult to provide for cargo build, you would like to use Logos Scaffold build, which will automatically detect and execute necessary build steps for you, depending on the template you used. It's gonna take a bit of time as well, but this is just because it's fresh.
You are watching Logos Dev Club. This is EcoDev engineer Sasha taking you through the Logos Scaffold project.
It's going to build all the dependencies, of course, but also the example programs. There are some quite heavy dependencies right now. We're looking to lighten it, and ideally it's gonna be much better once we will switch to Logos modules. So it's done. Building, we can deploy. We have a bunch of programs to deploy, so you can have like more than one, of course. So here you can see that you can deploy by program name, and the program name is the name of the program file without the extension. But in our case, we can just deploy all of them. There is limit how we can validate if the program was deployed. Well, Wallet did not throw anything at us. So here you can see the deployment command is quite, well, long. You can do it manually, of course, and you can also use the wallet CLI itself from LZ, but you also proxy it through the Scaffold. So because we are essentially running the wallet CLI under the hood, and we proxy the request there, you can use it like this. So here deployment is done. It was successful. Nothing weird has happened. If something weird happens, you might want to investigate it. As I said, refer to these folders, see the logs, see what's going on. If you need to seek help, then I advise to capture it by using report command. What report command does is that it captures all the possible information about the environment as well as the logs, the state. But also it does clean this a bit by removing the sensitive information. Unfortunately, there is a limit to how we can do it, so you must inspect it before submitting. But as a byproduct, you're gonna have a report for your case where you can attach this file or parts of this file once you unzip. This is just an archive. And you can seek help from community or core contributors. And that's it. Once you're done, you can stop your sequencer. You'll see all the logs here. And this is it to local scaffold. In future, I anticipate that we're gonna be reinventing this scaffold each and every version. So there will be a lot of breaking changes, but we'll try to have the surface as useful as possible. Thanks.
Thank you to Sasha.
Hello, I'm gonna show you.
That was the Logos Scaffold project, brand new. We will be right back with the next demo from Václav. Thank you for watching Logo Step Club. Please like and share if you have not yet. And we'll be back in just a moment with Václav with the Logos execution on Multisig. Next up, we have the demo from Václav for the multisig. As I pull that up as such and thusly, please say hello in the chat if you are watching. If you have any questions, certainly please do. Also, like, subscribe, turn notifications on wherever you might be watching. Logos.co is the beginning of your journey. It is the first, not the final destination. Go to logos.co. Václav also posted a thread along with this demo, and we'll go there thusly. So Václav says, this is a culmination of my work with Jimmy, the Claude bot, so far, smiley face. The Logos Network Blockchain Execution Zone program implementing the Multisig wallet. While working on that, we realized we need a bit more magic in the Logos Execution Zone. So we also built Spell, the smart program engine for Logos. I bet that gets into the Scaffold repo that we just saw from Sasha. Do you see how things come together, folks? And because we need to discover the programs or spells, as I like to call them, we also built a spell book, a program registry using the Logos Execution Zone to track programs and Logos storage to store IDL, the program interface schema. This demo shows all of the three working together. We interact with the multisig via spell CLI, and we register the programs in the spell book. And there are a number of GitHub links provided. I will provide this thread and the GitHub repos for both of these demos in the description for the video. Yes, all the repos need to be transferred to the logos.co.org. Yes, they do. And Jimmy finally touched real Logos storage for realsies. So we for realsies, we'll go now. You can find this video right there on Václav's X profile, V Pavlin. So let us go now.
This is the new name, and this allows you to do similar stuff as Anchor for Solana. So
my apologies. Give me one moment. We will be watching it from a different location. Let me give you just a bit of music here. Sorry for the delay here. One moment as I get things set up here. Oh, that's comfy. Okay. Here we go.
Hi, today I would like to introduce you to LEZ Multisig, which is what it sounds like. It's a multisig wallet living on Logos execution zone as a program, allowing for M of N signing, so M members signing out of N based on the threshold, and basically it's a standard process. So there is a multisig proposal, approval, execution, and then chain called to target program or programs. Now, I don't want to go through code today, but I have to mention a few things. This is based on a framework that I've called Spell, which is a smart program engine for Logos.
Spell gonna
Previously, we called it just LEZ framework. Now this is the new name, and this allows you to do similar stuff as Anchor for Solana. So it allows you to use Rust macros to define kind of the API of the program, and so that then allows for generation of set ATL, so instruction definition language, and then also CLI. So you don't have to write any CLI. This generation gives you that, and we'll use that actually throughout this demo. We'll also demo a spellbook, where spellbook is basically an on-chain registry for programs, which then allows you to fetch the IDL from Logos storage and use it in the CLI so that you can actually generate the transaction. And we will go through how that works. Now, in this repo, there is a branch, a tag called V01, and this is for our kind of current latest stable version. And the key part I want to point you to, apart from obviously all the code, there is this script directory which has a demo runbook, so you can basically do all that stuff manually that I'm going to show. But we also have a full demo flow script that does everything for you, and you can just watch it happen. And I'm going to use this just to make sure that I don't hit any issues. So there are a few prerequisites. First of all, we don't need to have sequencer running, but you have to have build, so cloned LSSA repo and build sequencer based on the README. We need the programs build, so there is a make build command in the make file for this in the multisig, and then also the spellbook, the registry. And then, this is incorrect. This now creates its own wallet directory so that we don't have to, so that we don't mess up your wallets in the home. There are a few environment variables that needs to be configured based on wherever your code lives. So you need to have the registry, the spellbook cloned. You need to have, this has old names, so I need to fix that. I'm sorry about this, but this should be either LEZ registry for the old name or the spellbook for the new name. This is the current directory, so this should just be pwd, current working directory, and this is the path to your cloned LSSA, and this is so that we are able to spin up the sequencer, because that's what the thing does as well. Now we have a bunch of other things. They may change and evolve, so we will try to keep an eye on this. We create the demo wallet directory so that we don't mess up anything that you would have in your default wallet directory in the multisig directory. So in this repo, demo/wallet, so you can always clean it up and remove it. And we're using this environment variable for the LEZ wallet and the sequencer, basically to find wallets. Now I think this is basically most of the setup, and after that we should be able to run it. So I'm just gonna clean this, and I'm just gonna echo LSSA there, which is empty. So I'm gonna set it, export LSSA there equals, and mine is in home vbablin double GitHub logos blockchain LSSA. Okay, and I believe that we should have the rest. I fixed some of the stuff here locally so that it actually fits in. So I have .lez registry for the spellbook program, and then pwd for the current directory for the current program. Now that I think about this, this may not be, oh no, it's okay, it's okay. Because I'm gonna just start it from here. So this is scripts and demo, demo. Now we can also do this, tail F, TMP, and let me find it here. We start the sequencer somewhere. Here's resetting sequencer, and the sequencer will log into a file, I think, wipe reset here to sequencer log file. So we're gonna tail that. I already have something there. So we're gonna start. So we've started the demo, and it's gonna tell us a lot of things that it's doing. You can see the mock codec storage here running. It would work with normal codec storage probably as well, or logo storage. I've never tried it yet. Just very simple REST API mimicking that, just for this particular demo, so that it's a bit more self-contained. Now we can see the sequencer is running. It's producing block, so block ID 3 is created. So let's move on. So what do we do now? Now we need to deploy our binaries. So we take a token binary, so we can work with tokens that should be already deployed actually, but we'll just see an error and it's gonna pass. We are taking our registry binary, we are taking our multisig binary, and we are deploying them all. You can see here that we have one error, which is program already exists. That's the token binary, and we have 2 validated transactions, which basically means that everything else succeeded. And here we are just waiting a few blocks to make sure that everything is fine, and we can see that the programs are deployed. We've also created a signer account. This will be an account that we will use to sign some of the stuff. Nothing special about that. It's just a new wallet account. Now we are calling registry register. This is again the rename to spell and spellbook happened after we tagged this version 0.1.0. So this is called the old name. It will be spellbook register, but this is fine. So it's registry register. We pass in some information. So we take the name of the program, we take the version, we take the CID of the IDL, the structure that describes how the program can be called with what instructions and things like that, and we submit it. So we have registered the token, we have registered the multisig. Now, next thing to do is we know that the registry is live, and we can fetch from the registry. So we can see that registry has 2 program registers. Amazing. So now we're good. So we're going to generate a bunch of new wallets. We're going to generate signer, which is going to be the initial member of our multisig. And we're going to generate member 2 and member 3. And we're going to submit some transactions. Here we are submitting create multisig transaction. This is going to auto-compute multisig state account, because LEZ has separated state account from programs. So program code has program code has separate account from the actual state, and then we are submitting the member accounts. And you can see the transaction has passed. We can see it here executed as so. And so now we have the multisig created, and we have the state PDA here. We can inspect it if we wanted to. Now the next thing is to do a proposal, and we're going to propose a second member. So we're going to create a new account using the wallet again, and we are saying using the multisig state, and we are doing a proposal for propose add member. We have special member management instructions. So these are not standard proposals. These are slightly modified because they are not interacting with an external program. But we have submitted that, and the proposal has been created. It's basically also auto-approved because we have 1 of 1 signers, right? The threshold is 1. We had just 1 member, and so it's basically auto-approved. So we can immediately execute. We don't have to wait for another approval. Now this is executed, which means that the code actually updated, or the multisig actually updated the signers. so the members of the multisig. And what we can do is that we can create another member, and we can propose it as well. So we're creating another proposal for a new member, and we have that automatically approved as well, because we still have threshold 1. So in the future step, we will actually bump the threshold. So now this is executed, and now we want to do a proposal to new threshold, because we now have 3 members and we want to do 2 out of 3 signing. You can see in the sequencer here on the right that these messages basically mean that something got executed in 14 milliseconds. It's a risk 0, so ZKVM, so the program gets executed in that ZKVM in 14 milliseconds, and then there is a new transaction, which is basically how we know that everything worked, is that we watch for this transaction to be included in a block, and when it happens, we get this confirmation based on our polling, right? So here we have proposed, using propose change threshold, new threshold to be 2. We've passed a bunch of other params. You can basically see that here. So it's transaction index 7, this instruction, propose change threshold, new threshold. The create key is an identifier of the multisig wallet, and then the proposal index. So basically it's an always incrementing index of a proposal, so that we can generate these proposal PDAs, these accounts that hold the proposals. Now this is proposed, and again, because it's auto approved, we can immediately execute, because we still had the threshold 1 for this. So now this was kind of lame, because we were just managing members, and that's kind of boring. But what we can do now is that we can actually do some token governance. So let's take a look at what's happening here. So we're gonna create this new, we're gonna calculate this new PDA for multisig. We call it multisig vault, but it's basically just PDA created based on the multisig program ID and create key, and we pass this PDA to a wallet token sent transaction. So we create a new token, we call it LEZ token, and so we now have some account holding 1 million of LEZ tokens, and we will fund this vault, right? And so we send a wallet token sent from to amount 500 transaction, and once that's approved, once that's processed by the sequencer, we will now do a proposal. So we have this token IDL JSON, which is same as the multisig IDL and the spellbook IDL. It's a definition of how to call program instructions on the token. We have derived it from the code. It's not generated like the others. But the IDL drives the serialization, right? So we don't have any hard coding of instructions, of the instruction bytes or anything. Based on this, we can use our CLI to generate a transaction data. And we do right exactly this. So this multisig binary is actually just a wrapper over the spell CLI. And so we pass it the token IDL JSON. And now the CLI, and I'm going to show that, generates, auto-generates the subcommands, instructions based on the token IDL. And what we do here is that we take the token binary so that we can derive the program ID. We pass dry run, which means we do not actually submit anything. We only create the instruction bytes. And then we take the transfer, or we call a transfer instruction and say amount to transfer is 200. And then we pass the accounts. So who is the holder, which is our vault, and who is the recipient, which is whoever, a newly generated wallet, basically. It doesn't really matter. And we say how much to transfer. And then we serialize it. And so this is basically the serialized instruction data. And we have all this other information that we can pass in, right? And based on that, we do a proposal. So we say, we propose that we will call a target program ID token program, and we will pass in this instruction data. And we will also, I believe, have to use some of the accounts. So we will pass in some of the accounts as well. And then we will submit this. And then that means that sequencer accepted that, and we now have a proposal that should send 200 LED tokens transfer as a chain call from the vault to some new address. And now we have to approve, right? So we have one member proposing, so we have 1 out of 3, and we need 2 out of 3 because obviously we have bumped the threshold. So we have Multisig approve proposal index 3, which is this third proposal, and the approver would be the account address of who is approving, and it has to be signed by that as well, right? And so this is exactly what happens here. Approver, proposal, multisig state, all passed in or calculated based on the parameters. And this is the instruction, approve. And as we submit it, it happened already, sorry. I need to put pauses on the right places. But basically, the N2 approved. So we now have 2 out of 3 and we can execute. And so what happens here, and that's super interesting, and I had so much trouble actually making it work because I made some stupid mistakes. But basically we call multisig execute and we pass in proposal index, which is 3, and the target accounts, which is what needs to be passed in for the actual transaction to be executed because the program expects accounts in a specific field, and so they have to be passed in a specific way. That's basically abstracted away by the CLI mostly. But we don't have to pass in the token program ID, we don't have to pass in the instruction data, we only have to say which accounts are part of this proposal and how this proposal is indexed, right? And then what happens is that if we go up here, we would see this is this. So we can see that there are 2 executions. And so that means that this is execution for the actual execute in the multisig program. But this second one is an execution of token program. That what it does is that it actually sends the 200 tokens from one account to another. And that's it. We can also do a lookup query. So calling registry info with program ID will give us the information registered in the spellbook. But we have went through all these steps, right? So we inspected some IDs, we've deployed all the programs on chain, we've registered stuff in spellbook, we have listed the spellbook, we've generated fresh accounts, created multisig, proposed a bunch of things and executed them, and then we have raised threshold, and then we are missing here step 10, which was the longest one, which is we actually did a proposal to approvals and a token transfer. Now, when I'm talking about this binary, right, the magic binary that kind of does it all, let me see, debug multisig, right? So if I just hit enter, it doesn't look like much, right? It's asking for an IDL file, and all things I can do is I can call init, which is just going to spit out a new project, and I can call inspect, which will print a program ID of a binary, which is very useful, honestly. And then we have PDA, which is also very useful if you need to calculate some PDA, like the vault PDA, the program defined account, derived account. So those are accounts that are managed by other programs. We need to calculate the address of this because it's derived deterministically. We can do it by calling this command. Now, we didn't pass the IDL, or we can do that. We have it here, and IDL, I think it's LEZ multisig FFI, because we also generate FFI for integration into Logoscore. And you can see that here we have multisig JSON. So if we call that, we get much more help, right? I'm gonna make it full screen. Sorry, it went wrong direction. So we get much more help. So we get a bunch of other options, and we get all these commands. All these commands are instructions implemented in the multisig program, auto-generated from the IDL, which is auto-generated from the code of the program, right? And so we can see all these parameters and all these things actually being provided for us. So when we can try, for example, create multisig, help, and it also gives us like create key, which is any string less than 32, what is the threshold of the multisig, and members which need to be passed in. And so we can then do this for registry, for the token. We can actually try it with the token IDL probably as well. So that will be in the LSSA there. LSSA there. But let me look, where is the token binary living? Token IDL is token bin. Where is our token IDL? Token. We seem to have a wrong token IDL here, but I think we have been using it here somewhere. So where is the dry run? Dry run token IDL here. Right, it's here in the same there. Sorry, scripts, because we have just auto-generated. Sorry, not manually generated it, so it's not there. And if we do this, we can see that these are all the commands or instructions that the token program allows us to do, and you can basically see them also here in wallet token new send burn mint, right? And so we have new fungible burn mint. This is a bit wrapped. This is very kind of raw based on the program. Anyway, this has been the demo. You can run this on your machine. Just make sure to clone, basically to clone these repositories. So they can be moved to Logos blockchain, LEZ multisig framework, spell, and spellbook. You don't need spell. You need spellbook and the LEZ framework. Check out the V010, and then there in the scripts, the demo flow should hopefully work for you the same way it did for me. I think this was too long. I'm sorry about that, but I'm very excited. It's very late now, so maybe it doesn't sound like that, but I'm very excited for this demo to actually finally work, where we can actually propose token transaction based on approvals in a multisig wallet on LEZ. Anyway, thank you for watching and listening. I hope it was useful, and have a good one.
Thank you to Václav for creating that demo. That is and was multisig functionality on the Logos execution zone via Václav's brand new concoction, Spell. I will have all of the pertinent repos and links in the description for this video on YouTube just as soon as we publish. One note, I do believe that the multisig framework, the LEZ multisig framework repo still needs to be transferred to logos-co, but you should be able to find it. I appreciate everyone for tuning in once again to Logos Dev Club. Every week, Logos Dev Club is here to bring you the latest in the technical updates, demos, presentations, research findings, both from core contributors and the community. Go now to logos.co/takeaction, as you see scrolling so beautifully across your screen, and sign up if you have not yet to stay updated on everything that there is to be updated on. And Parallel Society is this week, starting this Friday. Go now, ps.logos.co. Lisbon, March 6th and 7th, this Friday and Saturday, is Parallel Society. Day 1 is a technical conference, community organizing, arts, culture, hackathon, presentations, demos. Day 2, Saturday, is a music festival. Thank you very much once again for watching. Please like and subscribe and turn notifications on. We hit a milestone during this live stream, 1,300 subscribers to the Logos Network YouTube channel. Thank you very much for subscribing, for keeping your notifications on, and of course, liking the videos, both figuratively and literally. As Parallel Society takes place, we'll have a lighter schedule this week. We will be back very strong very soon with a lot more to keep you updated on. Until then, safe travels. Todo es mentira desde el mundo, todo es mentira, la verdad. The world is a lie, that lie is the truth. See you next time. Mahalo.